through what Macy is, why we need private voting nowadays, how the project works, some ideas on what you guys could build as we offer some bounties, and finally how you can build it. So Macy stands for Minimal Anti-Collusion Infrastructure, and basically it allows you to run private polls on chain. The main properties of it are collusion resistance, so only the coordinator can be certain of the validity of the vote. Resistance, you cannot prove behind any reasonable doubt how you voted to someone. Privacy, so only you as the voter and the coordinator can decrypt your vote. Votes are not censorable, and you cannot really edit or delete a vote, but you can nullify it. And finally, the coordinator cannot produce false output. Why do we need it? So there's a lot of quadratic funding and quadratic voting applications being built, and bribery is a very common problem because in this type of protocols, the majority of people can actually make a difference. If collusion is easy, then specifically for quadratic funding, the funds might go to projects which do not really deserve them. And at the same time, if your votes are public, you could also be conditioned, whereas if you don't really know how anyone else voted, you also might want to do more research on the projects you're voting for. And finally, which is kind of like the main gist of Macy, is that because you cannot really prove to someone how you voted, then why would they bribe you? Okay, so technical details. The architecture, we got three main components. So we got the smart contracts. These work only on EVM compatible chains. We got circuits. These are written in Circum, and we have a quadratic voting and non-quadratic voting flavor of it. These are used to process messages and tally the votes. Finally, we got some TypeScript utilities, which you can use to play the coordinator and then process the votes, interact with the protocol, both as a user or as coordinator, and some of the primitives which you can use to build on top of it. These include Macy public keys, encryption algorithms, and hashing algorithms as well. This is what the repo looks like. So if you do decide to hack on Macy, you probably won't touch the circuits. These are in red, whereas what you'll be using the most are the ones in blue, everything that is written in TypeScript. So within the CLI, you'll find an SDK to build a front end with it or whatever you choose. And the core will be the clone of the smart contracts, which is used to process messages and generate inputs for the circuits. Finally, we got the smart contracts written, the one in the green, and you'll find test, deployment scripts, and everything you need there. So as a user, the first thing you would do when you interact with Macy is you create a Macy key pair. So this is your identity in the Macy system, and that is not to be confused with a Ethereum public key. This is the serialized form. You can see it here. Basically, this is a point on an elliptic curve. Won't dive on the math part of it. But when you register, you send your public key, and this is stored on a Merkle tree on chain. When you vote, you will take the key of the coordinator and use ETHGlobal to generate a shared key. This way, you encrypt the message. So whatever you send on chain is all encrypted. But when the coordinator pulls the data off chain, they'll be able to reverse the encryption. You also sign your vote, so no one can really publish a vote for you. Finally, you might want to verify that everything was done correctly. So that would be after all of the processing is done, and you'll be able to interact with the smart contracts and make CK proofs to just verify that the result of the poll was conducted in a correct way. This is what the coordinator does. So fast forward to the end of a voting round. The coordinator will merge the Merkle trees like structures, pull all of the events from the smart contracts and generate the state locally. So this is like a copy of whatever happened on chain. And from there, they run this TypeScript code to process the messages. So you decrypt the message, you verify that the message is valid, and then we go and generate snark proofs. These proofs are submitted on chain to one of the smart contracts, and there's some commitments to this data. The same is done as well for the vote tallying. We assume that the coordinator is honest, but it's also true that what they could do is they could actually collude with bribers themselves. Currently, as the protocol stands, there are some work in the pipeline to improve on that, but technically they could decrypt the votes and just publish them, or they could just decide to not conclude the vote. But some of the good stuff is they cannot really censor any of the votes, and that is thanks to the smart contracts, and they cannot perform any incorrect processing thanks to the zk-SNARK circuits. Everything that is to consider the source of truth will be on chain. So we will have the root of a tree holding the signups, the root of the tree holding the messages, the number of users that signed up, the number of messages. So whenever a user or the coordinator tries to verify the proofs, this data will be pulled from the smart contracts. And let's say the coordinator is trying to say, I process all the messages, but it only sends data for 99 messages when there were 100, the proofs will not validate, and user would know that. Right, so for the hackathon, some of the stuff you guys could build if you wish to. Like quadratic funding applications, there's a few of these. You can take inspiration from them if you want, like Fun, for instance. DAO voting apps or toolings for DAO voting. Some Sybil resistance mechanisms for Macy, so like gatekeepers contracts. There's some cool ideas like using this proof of personhood, like proof of passport or whatnot. So like only users that using ZK proof they're human can join a Macy poll, or even like build some front ends for them, like one to manage or one just to contribute. We have a discussion here on GitHub. I'll share this later on so you can just click on it. And all of these projects are there and a few more as well. In terms of how you can build on it, we're going to be looking at the smart contracts here. So we got the user and the coordinator, right? So the coordinator deploys the Macy smart contracts alongside this gatekeeper and a voice credit proxy. You as a user, or anyone as a user, signs up with their key, and the smart contract will make these calls, and this simply answers, can I sign up? So do I pass certain criteria, which you decide? Or, and this one, how many votes credits do I get? So like, what is my voting power in this poll? This can be like a constant value, everyone gets the same. Some people get more because, let's say in a quadratic funding protocol, they contributed money to the matching pool. It's just up to you to decide as the builder. Then the coordinator can deploy polls. Calling this function will basically trigger 3 deployments: a poll contract, a message processor, and a tally. The poll one is where the votes are sent. So you as the user will just call directly this contract and send your votes. The message processor is for coordinators to submit proofs of correct message processing, and so is the tally. But on top of that, in the tally, you can actually call some functions from the user perspective to verify that everything was done properly. So just one example here is a very simple quadratic funding protocol I tried to build using Macy. This is like the main contract, which inherits from Macy. So within the constructor, we pass all the parameters the Macy needs, plus a few more that we need. So because this is a quadratic funding, we need a token so user can contribute to, and a recipient registry is just a list holding the addresses of the projects that are part of this round. Here, something that you might do as well if you build and you change the contracts, is overriding the sign-up function. So as you see here, we call in the normal Macy one, but on top of that, we are taking some funds from the user and storing how much they contributed there. Again, like if you change any of these three concepts that I showed here, you can extend the deploy poll function to do the deployment plus extra. So I extended the tally contract to have an initialize function. So here I can just call it as well. And here is like the tally one. So what's interesting here is as a user, or well, as a project part of a round, if you want to, when it's time to claim the funds, so when all of the messages have been processed and the ballots have been tallied, so the results are there publicly available, anyone can trigger this function, send the snark proof, the vote option index. So imagine an array of projects. Let's say we want to send the funds to the first project. This will verify that the TK snark proof is correct. And however many funds or votes they will be receiving. And yeah, in terms of bounties, we got 5 bounties, but I thought the medals look cool. So you got 1, 2, 3, 2,500 for the first, then 1,500, 1,000, 4 and 5th was split 1,000, 50-50, so 500 each. And you know, if you do decide to build, feel free to come to me. We can talk ideas and whatnot. And yeah, again, to conclude, we think that privacy is very important, and especially private voting. We hope there's a future to this, and we do hope the Macy can help make a difference. There's a lot of work that needs to be done, and it's nice to come to hackathons and get your support, or even if after this you guys are happy to just give some open source contributions. We're always open to hearing your ideas and helping you collaborate. If you want to reach out, there's Discord invite for the PSC channel. And yeah, like if you got any questions, now's the time. Yeah. Oh, well, I'm done. Yeah, I mean, if you have questions, really, yeah. Sweet.
I just have a question regarding the...
Oops, sorry. Could you say that again?
Yeah, I just have a question. You generate a share secret between a user and also the contract?
It's cool.
Yeah, so the client will generate a public and private key for that. But I was curious about the private key that would be used for the share secret. Which one owns it? Is it the deployer of the contract? Or,
Okay, right, so you have your own private and public. So that's the coordinator. So the coordinator will publish their public key, okay? You, when it's time to encrypt your vote, you generate a random key at that time, okay? So for each vote, you can generate a random key. You take the private key and the coordinator public key, use the CDH to generate the share key. You encrypt with the share key, and then you send alongside the message this random public key. So the coordinator takes the message, takes the random public key, their own private key, and they get the same encryption key. Does that make sense, yeah? Sweet. Anyone else? Of course, yeah?
so in this case, you need to be sure that the deployer will be trusted, because it will manage all the private encryption during the process.
Correct, yeah. So we assume that the... Oh, okay.
Yeah, and to continue with that, we just assume that the one that going to deploy the smart contract that going to generate a share secret, it is trusted in the process, right?
Yes. So I mean, technically, the deployer doesn't need to be this trusted party because they only need the public key, right? So anyone could deploy and then send this coordinator public key. But yeah, there's some level of trust on this coordinator to do to do everything because they can encrypt the vote and can just share them with drivers, for instance. There's some work being done on preventing this, but it's not there in production yet. But yeah, for now, that's the case, yeah. Good question, though. Thank you. Hi.
Hello. Yeah. In one moment of the process, we register the all participants. I mean, when in the start, I mean, in one moment you have 20 address, they're going to vote. You need to. It's a process. It's a moment when you need to register that. That's correct.
You as a voter, you mean?
Yes, I have at least 20 voters in one moment before I can generate the proof. I assuming is a moment.
You can register anytime within the poll duration. So let's say the poll ends tomorrow midnight. You can register anytime before that, and your votes for that poll will count because you signed up in the correct, just before the deadline, basically.
Hi, I wanted to ask you, I was reading that there are some technical limitations to bigger amounts of voters. Could you please explain a little bit about that?
Good.
If there are, and what are these limitations?
Could you expand on that? Like what type of issues?
So I was reading that there's limitations for bigger amount of voters. That's what I was reading on, I think, one of the repos or one of the articles which was explaining it.
Okay. Yeah, so basically the amount of voters is based on the capacity of the Merkle tree. So as the Merkle tree goes larger in depth, you can accept more voters at the cost of like proving time. So generating a proof will be a bit longer for the coordinator because the circuit will have much more constraints. So yeah, but technically, so we run a trusted setup ceremony for the current version of the circuits, and yeah, the one that we have in production after the ceremony is only maybe 15,000 signups. But for instance, we could run another ceremony with increasing this parameter to support 1 million. The only cost there would just be the proving time, basically.
Any more questions? Okay, so thank you guys for showing up. Thank you, Control C.
Thank you.
And
Thanks, guys.
that's it. Paul from Cello, and this is our next workshop about building a mini app, the app.
Great, yeah, thank you. Thank you for being here, and GM to everyone. So in this workshop, you're going to learn how to build dApps on MiniPay. So I'm going to talk a little bit about Cello first, and then Cell2, and then MiniPay. So at Cello, we believe in the principle that you should build with purpose. So whenever you're building dApps, build with the ideology that somebody is going to have, your app is going to make a real world impact on someone, right? And you build for everyone. You don't build for people just in the Web3 space or to specific users. So what is Cello? Cello is a EVM compatible L1, so you can use your Solidity contracts. They work right out of the box on Cello, and we are transitioning to a layer 2 soon. We are built for ease of use, so we highly focus on mobile and abstracting a lot of information about what is gas, and also we don't even make it necessary for the user to have the Cello native token to do transactions. You can also use other stable coins in the ecosystem to do transactions as well. So yeah, gas is payable by tokens, which are stable currencies. And this is not the account abstraction thing. This is plain EOAs without paymasters are allowed to do transactions using stable coins. We're also carbon negative, which means that every transaction that happens on the blockchain contributes to a carbon fund, which is then used to sponsor carbon negative projects. This is a very brief overview of the Cello ecosystem. There are many services, and many of them are probably also present here at the hackathon, so feel free to stack bounties and be eligible for them. A little bit about Cell2, which is the layer 2 that we are going to be soon. Once the stack selection is done, there are 4 stacks under consideration right now: OP stack, ZK stack, Polygon CDK, and Arbitrum Orbit. So once the stack selection process is done, we estimate that we will be ready with the Cello rollup in 2 months, then integration with the data availability layer in about 1 to 3 months, decentralized sequencers, and then do pre-mainnet, where we'll give access to people to play around with the testnet, and then go mainnet. You can find a lot more information about what the Cell2 migration looks like on forum.cello.org. There are many proposals and many discussions happening there, so if you want to catch up on this, forum.cello.org is the best place. We also do Twitter spaces with very influenced people in this space, so if you just want to learn more about L2s in general, then I highly recommend following @Cello on Twitter, and you will get notifications about all the L2 podcasts that we do. The last one we did was with ZK Sync. A little bit about MiniPay now. So MiniPay is basically a wallet which is integrated in the Opera Mini browser, and it mostly focuses on stablecoins. So it does not support other currencies. Right now, the only currency it supports is Cello dollars. It's very affordable and fast because it's built on the Cello blockchain, and it is designed for ease of use for people in Africa, and right now it's only available to few countries in Africa. The objective is that the wallet should be so simple that the user does not know that they are using blockchain behind the scenes, that they are using crypto, any of that, right? They just should be able to do what they want to do. They don't need any extra information. Now, why you should build on MiniPay, right? Because first thing is that Opera is a very big user base, right? They have over 80 million active users. So all these users can be potential users for your own dApp. So why not build for that? The access to MiniPay wallet is extremely seamless because people already have the Opera browser in their phone. MiniPay is just a menu item in the browser itself, so they don't have to install any other apps to access the wallet. If you are going to take your project after the hackathon, you're going to take it go to market, or like you're going to figure out product market fit, then you don't have to also think about customer acquisition costs, because the users are already in the wallet, they're already using the wallet, and your app already sits inside the wallet, so they are going to come across your app anyways. So you will get all these users coming in from day one, and over 10K new users join MiniPay every day, and which can also be new users for your dApp as well. So why not build for it, right? And recently, just a few days back, we crossed 2 million users. And this is just coming from 3 countries in Africa. We are not even rolled out worldwide. So you can expect a lot more users coming in once we roll out worldwide with Opera Mini. The best place to learn about MiniPay is docs.cello.org. The first link will take you to the page where you can learn more about how to build on MiniPay, etc. So enough of talking now. Let's just go into hacking mode and build something, right? So if you go to this link called cello.org ETHGlobal MiniPay workshop, you will be able to find all the steps that you need in order to build on MiniPay. So the first thing that you will need is you will need Node and Yarn, and then you can run the npx command. This is a template that we have built specifically for the hackathons. You run this command and you will be able to set up your project in like less than 15 minutes with a good internet connection. So I've already done this step, so I won't be doing it, but to just give you a glance of how it will look like, let's see. I can run this command here, and it just asks you for a project name. So ETHGlobal MiniPay Workshop 2, and that's it. The project is already set up. Now all you have to do is go into that folder. Let's say ETHGlobal MiniPay Workshop 2. And all you have to do is run the command to install dependencies, which is yarn, and your project is ready to go. And if you want like testnet tokens, and surprisingly a lot of people obviously need testnet tokens, but they don't know where to go. So this is a link, faucet.cello.org. All you have to do is just put your address here, and if you want stable coins, which I highly recommend, just uncheck Cello only, and you will also get the stable coins that you would need in order to make your app on, because MiniPay only supports Cello dollars. So you need Cello dollars on testnet, and this is how you get it. The other thing is that if you don't have an Android device, because MiniPay is an Android app right now, like the Opera Mini browser is an Android app and MiniPay sits inside it. So if you don't have an Android phone, you can use Android Studio. And if you click on this link, we have steps on how to install Android Studio, and how to install the emulator, and which emulator to install. So one thing I want to highlight is that if you're using Android Studio, install the emulator which has the Play Store icon along it, because that is necessary for, you need Google Play services in order to sign up for MiniPay. The next thing is how do you install the MiniPay app on the emulator. So we have steps for that as well. Let's see, if you go to the docs page, if you go to build on MiniPay, and if you scroll down, you will see the section for installing MiniPay. All you have to do is install the browser, which is Opera Mini Beta. This is an Android app. And then you click on the Access MiniPay link, and it will give you access to MiniPay in your Android phone or your emulator. I've already done these steps. The other thing is that by default, MiniPay is mainnet because it's for users. But since we are here building projects, you would want to enable testnet on the app. So we have steps on that as well. I can show it to you right now. So this is the MiniPay app. If you scroll down here and if you go to the settings icon, you can go to About, and you can click on the version number for 10 times and you will be able to access developer settings. So I already have the developer settings on. If I click here, you will be able to enable developer mode and testnet. This is how MiniPay will then run on testnet, and whatever apps you open, they will be on testnet. So that's there. What's the next step? Where did my mouse go? Yeah. So the next step is setting up ngrok. So this is again specifically for people who are using the emulator, because whenever you're building projects, you are building on local-host. So how do you share your local host with the MiniPay app? And to demonstrate that, what I can do is, let's do it right now. So this is the project I have set up already, and I will use the command that runs the project. So, okay, so the project is now live on localhost. Let's open it up. If we go here, paste it. This is what you get when you use the command that I showed in the beginning on setting up the project. Now the problem is that this is on localhost, and if you go to your MiniPay app, and if you click this explore icon here, you can scroll down. These are the different apps which are already live inside MiniPay. But if you go down, we have one extra app for developers, which is Site Tester. All you have to do is paste a link to your dApp here, and your dApp has to be a web dApp. So probably everybody is going to build a web version of a Web3 dApp, right? So all you have to do is just paste a link here and make sure that your dApp is mobile responsive. If it's mobile responsive, it's going to look good on MiniPay, and you are eligible for the MiniPay bounty. Seriously, that's it. You have to deploy your project on Cello and make your web dApp mobile responsive, and it will work here. Now the problem is I cannot take the localhost. Yeah, you can open them up. You can open desktop sites as well. It's just that it won't look good. That's all. Yes, it should be optimized for a mobile user, because the user is going to come through a mobile. They're not going to use a desktop. So you want to be mobile optimized. Now again, continuing. I cannot take this link and just paste it here because it's localhost, so the phone will definitely not understand it. So how do we, share our localhost with the app? So for that we have ngrok. I just type ngrok, HTTP, and the port number, which is 3000. So now I get a link, which is this one. This link can open on any machine in the world, right? So I will just take that link, paste it here, and hit go. Let's see. Let's do it again. Oh, sorry. Sorry? Yes, it is HTTPS. So let me try again. Cool. So this is a one-time warning that you will get from ngrok. And if you click visit site, we have if it loads, we have the same app now running inside MiniPay. So this is your local host and this is your MiniPay. And now you can click on buttons here and you will get requests. So this is how a wallet prompt will look like. And when you click on withdraw, it's going to ask for the user's biometrics. And for this phone, it's a pattern. So I'm going to use a pattern. And yeah, that's how users will be transacting when they're using MiniPay. They don't have any seed phrase. They don't have wallet address. So yeah, it's pretty seamless. Matter of fact, you can, like, if I go back and I show you, if I want to send some funds to someone, I only have to use their phone number. I don't even need to know their wallet address. You just type someone's phone number and send them value. That's it. No wallet addresses, nothing like that. So that's there. Site. So in this link, we also have the instructions on how to do the testing or using Site Tester as well. So these are the same instructions that I just followed. And that's it. Then we have links for other resources, like some guidelines on how your app should be. For example, we encourage that you don't have a connect wallet button because the user only has one account. So there is no account choosing screen. You just connect to the wallet directly. The user never sees a button. They don't know what connect wallet is. They don't know what switch network is. Nothing. Just open the app and get started.
Their identification is their phone number, right?
Yes. So that's one guideline. The other thing is we have this code library as well. So very common functions like transferring tokens, checking their CUSD balance in your dApp. All of this code is already available. And I highly recommend using the VM library rather than the ethers, because VM library has some extra features that would make your app compatible with MiniPay. Ethers might give you a lot of bugs, so I highly recommend using VM. And we also have some more guides on how you can use other libraries if you are not using VM, or if you're not using the template that we gave you. Even if you're not using that, there are instructions on how you can make it compatible with the MiniPay dApp. So that was about building on MiniPay. Here are some ideas for the hackathon. The personal finance apps, stablecoin yield apps, gift cards, coupons. We already have an app for scratch cards, which is more like you scratch cards, you get rewards for doing something, for example, holding tokens or interacting with some dApp, doing transactions, etc. Billing inside MiniPay is not there. So, for example, merchants want to use it for receiving payments. They want to have a dashboard where they can know who has paid, when did they pay, analytics, monthly earnings, weekly earnings, daily earnings. Nothing like that is available right now. Micro work marketplace, there are two sides of the party. People post work, the other side of the people do the work and claim funds inside MiniPay. That is also something that we're looking out for. This is a QR code that you definitely want. If you scan this, it has all the resources, everything you need in one place. This is the only link that you need during the entire hackathon, to be honest, from a Celo standpoint. So I will let people scan this. Cool. And faucets. Again, a lot of people ask for faucets. So faucet.celo.org. You can get all the testnet tokens you want from there. If you face any problems, please come to our booth. Talking about the bounties, sure. Cool. Talking about bounties, if you build the best app on MiniPay and you win the first place, you will get 4,000 USDC, second place 3,000 USDC, and third place 2,000 USDC. And we also have a bounty with Mento Stables, the team behind the stable coins that we have, Celo Dollar, Celo Real, or Celo Euro. These are the 3 stable coins already active in the ecosystem. And if you build something exciting with these stable coins, then you get also 1,000 USDC. Friends at ETHGlobal. So these are the other projects that are also at ETHGlobal, and if you want to stack bounties, these are the projects that you should look out for. All of these projects support Celo blockchain. So if you want to stack bounties, which I know many of you would, so these are the sponsors you want to go with. And finally, find us at ETHGlobal booth. And if you want to ask questions async and we are not available at the booth for some reason, then you can go to Partner Celo channel on ETHGlobal Discord. And we are monitoring that channel for questions. So yeah, that's it. Thank you. Any questions? Yeah, sure, go.
When is it going to be on iPhone?
iPhone, soon. We don't have a date, but soon, yeah.
As a web app? As a progressive web app?
Progressive web app. It's already a progressive web app, but it's only accessible via the MiniPay Opera Mini browser.
And, the mini browser is not on iPhone yet. So.
Yeah, it's not on the iPhone. Yes, yeah.
Can we open Podcaster
I think, yeah, that is a hard one. Yeah, I don't think you will be able to do that. But even if you do that, I think you will have to log in via broadcast to the process. I would say that give it a try. Try opening a broadcast.com inside the site tester, yeah, and logging in and see if it shows you your feed.
Okay.
Yeah.
So, but we will still be able to make payments via MiniPay.
Yes.
Thank you.
Any question?
Yeah, so when you were demoing the MiniPay application and it had a web browser on the side where you connected to your Ngrok application, was that Ngrok application just a dApp that uses like Veeam and whatever? And then
yeah, it was a dApp. It was a web dApp. Simple web dApp uses Veeam. And I just run it on my local host, and I just use Ngrok to share my local host with MiniPay.
Oh, yeah, awesome.
Normal web dApp, yeah.
Oh, wait.
Yeah.
Awesome. Thanks.
Yeah. Cool. Sure.
What happens when you send money to like sorry, can you only send money to like the phone accounts in those countries, or like can I send money to like one of my friends in London or something?
Yeah, that's a good question. So anybody who is registered on MiniPay, you can send them funds to their wallet, their phone number.
And if they're not, if they don't have MiniPay yet?
Yeah. Then they have to go through the MiniPay onboarding process.
So they get like an SMS message?
Yes.
Okay.
When they do the onboarding, they get an SMS message.
Okay,
yeah.
cool.
Yeah.
Our next workshop is held by Luke from ENS about identity in your apps. And guys, if you have a question, please let me know so I can give the microphone to you.
All right, let me check how I sound like this. Can everybody hear me? All right, awesome. Okay, I'm going to be bent over like half of the talk because one of the microphones is not working. So, this is what we have to work with. We're good? Can I stand here too? All right, awesome. Let me see if I can. There we go. So, Web3 identity, ENS. I had too much caffeine, so my apologies in advance if I go a little too fast, but I'm sure it'll be okay. Raise your hand here if you have an ENS name. Awesome. That's what we like to see. Hopefully we can get that to like near 100% sometime soon, but we'll get there. So, quick agenda in no particular order of what to expect because most talks have an agenda. It doesn't really matter. What I'm going to cover, what ENS is, top-level domains, Web3 identity, developers, our new documentation, and obviously some cool stuff about the ENS cards. We're not printing them here, I'm sorry, but, that's life. So, what's ENS? Super simple. ENS is a decentralized, permissionless naming protocol that lives on Ethereum and scales to the entire internet. And what that essentially means is that I am 0x225F1371213C35, otherwise known as Luke.eth, which in my opinion, is a whole lot neater and nicely fits on a card. So, where traditional DNS would help us convert google.com to an IP address, ENS allows us to take human-readable names and turn them into machine-readable identifiers, such as crypto addresses, Bitcoin addresses, and much more. Anywhere you can write an ENS address, or an address, a crypto address, or anything of the sorts, you should be able to write an ENS. So in this case, this is an Etherscan example. Let's be real, who wants to see this? And everyone wants to see a name. I went too far away from the mic, didn't I? Here's some more examples in your favorite application, your favorite wallet, your favorite dApp. You just type in the name, and then it resolves to some address, and then you can send some funds, you can interact, or you can chat with your friends. Same story in the top right of almost every dApp you've ever used. ENS is the primary way of doing identity in every Web3 application. We are trustless, we're decentralized, and we're on Ethereum mainnet. As well as on a ton of other applications and a ton of other subdomain systems and gateways and much more. This is a snapshot of the ENS manager, ens.app or app.ens.domains. So why? Why care? I care because ENS is fun, it's cool, it's portable, it's extensible, it's multi-chain, it's a public good, it's decentralized, and it improves crypto UX. And it's just a super cool public good. I mean, what more do you want? So ENS aims to extend DNS. And with that, we aim to extend .com, .xyz, and much, much more. So if you have a .io, a .xyz, a .finance, a .cash, or anything of the sorts, it'll work within ENS. And any of the other 2,000 some odd DNSSEC top-level domains that for some reason I happen to know most of because I've spent too much time in this space. So how? How does ENS work? Super simple. ENS uses a resolution process, and that's all we are. We are just how to look something up, and you're in charge of the rest. TLDR, smart contract go burr. The way that works is super simple. I'm going to give an example. Don't get too scared. I'm not going to go super in-depth. Just kidding, I am. And we'll get there, but I'll spare you most of the details. So the way it works is super simple. I'm Luke.eth. Here's how we see it in an application. And every name has a resolver. In this case, the resolver is a smart contract that's responsible for my name. So when I look up Luke.eth, I get some information from this smart contract that we call the resolver, and it tells you everything you need to know about the name. The way that works is super simple. There's a smart contract on Ethereum mainnet called the registry. Anytime we do a lookup, we say, hey, registry, who's Luke.eth? And the registry will say, oh, I know .eth. It's done by that smart contract. And then it goes to another smart contract. So in the same way that with DNS, we have a hierarchy of DNS servers, we have a DNSSEC chain of trust, we have an SSL chain of trust and certificates in that way, we have Ethereum smart contracts referencing each other and keeping links to one another. So we've got the ETH registry. Amazing. There are also .com one, there's an XYZ one, and there's custom ones for some of the TLDs. Most of them use the DNS registry one, but I'm going to be focusing on ETH specifically. So the .eth registry has another table that it keeps track of all of the .eth names, in this case Luke, Greg, and Makoto, and a ton more, as well as the contract responsible for each. And in my case, that's the public resolver, which is this lovely contract. And here comes the cool part. That contract right there, you have the ability to change, because if you own Luke.eth, you control what contract is in charge of resolution. And what this means is that you can write your magic in a smart contract and say, I want subdomains, I want profile picture depending on the day of the week, I want a funny username, I want whatever, and it will magically work. So there's this lovely long EIP 137 that introduced ENS. It defines how a resolver works. It doesn't really matter. The long story short is there's ADDR, name, ABI, pub key, and like 10 more. And the way it works is super simple. You write your contract, you add an ADDR function. Anytime somebody does a name lookup using your contract, the name gets inputted as a variable. And in this case, I was the stubborn developer and I hard-coded in my own address because all your money should go to me. I'm kidding. I'm kidding. Sweet. So here's our lovely function, and it returns 0x225f13712134, yeah, whatever. There's also the text function that allows you to return any text record. So if you're interested in someone's avatar, someone's header, someone's banner, someone's Twitter, I don't know, anything else, it can return it as well. This can obviously be way better and way cooler than hard-coded. Right now, this is a call lookup, and it just returns some hard-coded data, but you could load it from an NFT collection, you could load it from a governance scheme, you could load it from participation bills, you can do all sorts of cool stuff and load it from places. This could be whatever you can imagine. Whew. Okay, we did the most parts, just kidding, we're gonna keep going. Thank you for not leaving. What about subnames? So, are you ready? Take a deep breath. Here we go. Super simple. Here's loop.eth again, hello.loop.eth in this case. We go out to the ENS registry. Hey, where's hello.loop.eth? Ooh, I know this ETH registry thing that has this resolver thing that has this magic. Amazing. We do our lookup, our magical code runs, it looks up hello.loop.eth and it says, I would like the avatar and the address, please. Our code does some magic. GG, easy. Next. That was it. Now you know how to build a subdomain registrar, how to give out subnames, how to set records, how to do dynamic things, and much, much more. So, super simple. You bring the resolver, we bring the resolution. And that's it. We're an open protocol, and anybody can build one. Very nice. So, you thought that was over? No. There's way more cool stuff. Text records. Text records lets us store anything you can imagine. No longer are we just storing a Bitcoin address, a Litecoin address, a Dogecoin address, a Dogecoin address, a Dogecoin address, a Dogecoin address, and a bunch of ETH addresses, Optimism addresses, Arbitrum addresses, much, much more, but we can store any arbitrary text value. This could be a verifiable credential. This could be proof that you're over 21. This could be your profile picture. This could be, you name it, your pronouns. You put them there. It's that one, right there, the avatar one. Remember that? Sweet! There's a ton of them that we standardized, but you could, technically speaking, use whatever you want, and so long as apps want to load the information and care, they can do so. Obviously, we recommend you write a standard so that everybody can build tooling and everybody can enjoy, but you're more than welcome to make up your own records as you go. A couple examples of some cool records are the display record, in case your name is multiple syllables long or something along those lines, and you'd like custom capitalization. The avatar record to set your avatar. This can be an IPFS hash, a swarm hash, an Arweave hash, you name it, anything of the sorts, or just a link to your Twitter profile picture. A description, keywords, email, you name it, you can put it in an ENS name. Sweet. Another cool one is, for example, the DM3 profile. You can store info about where people can reach out to you, where people can encrypt messages with, and much more. The header, so you can store a banner image. The time zone, because everybody should be in UTC. Come on, guys, what is this? No, I'm joking. But the time zone, so you can store your time zone. Whatever other thing you can imagine, a CK proof for age, or anything of the sorts. A color scheme, but light mode should be the only option, but whatever, some people disagree. Com.Twitter, your Twitter username. Com.GitHub, your GitHub username. Telegram, basically whatever you want. Your app.hello. Got it? Cool? Sweet. So, where can I get one? Where can I use them? Identity. ENS on the ENS app will show all your records nicely, as well as on any other app you can imagine. So here's some of my beautiful records. Here's a screenshot of snapshots. So let's say you're dealing with governance. Nobody wants to see 0x225f13712 blah, 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 voting yes or no. Everyone wants to see names, because names are nice, and names are human readable, and names give us identity. Immutable records. Uniswap is phenomenal, and they use subnames to be able to keep track of where deployments are on certain chains. Uniswap uses ENS names for copyright. Chainlink uses subdomains to be able to keep track of data sources. So if you want to get the USDC ETH price on mainnet, you can just look up the Chainlink name. Decentralized protocols such as Farcaster, letting you set the profile picture and an avatar and a name. Web3 messaging like Coinbase with XMTP, as well as many others. And just letting users enter names. Any text box, a user can enter an address, a user should be able to enter a name. Because it's so much easier to claim a POAP to Luke.eth than it is to claim a POAP to 0x. Okay, I'll stop, I'm sorry. Oh, what did I do? All right, it's really that simple. So, you want one, I get it. If you want a .eth, second layer, Luke.eth, Anthony.eth, etc. You can go to ens.app, and it'll be $5 a year worth of ETH plus some gas fees. We understand this might be high, so there's many other options. Uniswap is one of these. They issue subnames using the Uniswap wallet. Coinbase is one of these. If you want the cb.id, they use the Coinbase wallet. Anybody that uses the Coinbase wallet completely for free can enter in their information, request a name, and get a subname from Coinbase. And this uses that same resolver logic I showed you before, and it doesn't require anything else. Argent with argent.xyz, Lens with lens.xyz. GoDaddy recently added a tab where any Web2 domain, your .cash, your .finance, your .fi, your .nl, your .co.uk, you name it, you go to the Web3 tab, you enable it, you type in your address, and it magically works completely for free, instantaneously. Or any other DNS provider. The steps there are one extra step, you enable DNSSEC, and you set a text record. Easy. Want to build your own naming system? Do it. Implement ENS and work everywhere. Not just in Uniswap, not just in a wallet, but in any Web3 application that supports ENS. We're an open protocol, and anybody can build with it. So, let's build. If you're building on ENS, super simple. We built a design system because I suck at making things look good. So if you scan the QR code, you can use pre-built components. You don't have to worry about anything. It'll look nice. It'll work. It'll be great. I'll give you half a second to scan that. Don't worry, there'll be more. ENS.js, a library that lets you fetch any kind of information you can imagine, when a name expires, when it enters grace period, and anything else. Oh, sorry. Here you go. Don't worry, they'll be at the end as well. Fresh documentation. We just revamped our entire documentation. So anybody can go to docs.ens.domains or scan the lovely QR code and view our new docs that have dark mode. Ooh, I hear people like that. I don't know, I'm a light mode user. New documentation completely rewritten from scratch, containing anything and everything you might want to know about the protocol, as well as guides to walk you through. Issuing subnames, easy peasy. Here's the URL to the guide. If this is something you want to build, we have a couple hackathon prizes open. I think we also have a hackathon bounty set for adding some better support to a couple open source libraries. So if you're not feeling like building something new and you want to work on an existing library, make a contribution to open source and get those lovely green squares on GitHub, and a sweet bounty, we're here for that as well, and we're happy to help. And that was it. Or not. Figma disagrees. That was not it. But this is the end of my talk. Thank you for being here, and I'll be at the ENS booth all weekend. So if you have any more questions, I'm happy to help. Sweet.
How about L2s, like optimism based? Like, how do you, because if you have to pay gas fees on Ethereum every time you want to update a record, it's going to be really costly.
Completely understandable. So here's the deal. ENS allows you to store your data anywhere. Leveraging EIP 3668, don't worry, it'll be in the docs, otherwise known as CCIP read, you can load any information from any chain. So if a user wanted to, they could store their information on Optimism, Arbitrum, Polygon, you name it. We've built the EVM gateway, which you'll also find in the docs, which allows you to trustlessly load information from the aforementioned, which means that users can now migrate their data and store it on other chains. Now, obviously, this is still something we're heavily in development with, but at this point in time, anybody could build a system that allows them to give out subnames on Optimism, or give out subnames on Polygon, or give out subnames completely for free off-chain. And the way that works is you write a resolver, and then in your resolver function where you put that magic, you revert with off-chain lookup, where it should load the data from, or you use the EVM gateway right there, and then it will load the data, and it will work.
I just want to know, does the resolver, the contract that you write, does it work for testnets also?
Yep. We've got deployments on Haleski, Gurley, Sepolia, and I think all the other ones as well, but you know, testnets have a limited lifespan. But if you want to, I think we also have a couple of faucets that we're linking out to in the docs. So if you need some testnet tokens, you'll be able to test out on there. But yeah, all of the deployments are on there, and you can mess around with it, for sure.
Okay, and the last question.
You mentioned, yeah, very short. You mentioned Coinbase and Uniswap have a gasless experience for the building subnames.
Yep.
And is this to the point you touched on that you can create your own resolver on L2s? So that means they're hooking you up with the smart wallet accounts for 337. Is that how it works?
Yep, exactly. So here's the steps. Write a contract, deploy it to the L2 of your choice, and it's super simple. Most likely, if you're working with 43C7, you'll have a factory contract that creates proxies, right? And then while you're doing your proxy creation, just make sure that in some storage slot in your contract, you store some funny name that the user prefers or that's still available, and the address of where their contract got deployed to. Should be super simple to do. Add some view functions to the contract that allow it to become a resolver and allow it to look up information from that aforementioned storage slot of your choosing, and then it will work. And then you'll write a contract on mainnet, resolver that reverts to load from the L2, and then everything will work and hook up. Yeah. Sweet.
Awesome.
Thank you very much.
Thank you.
Okay, just give me a thumbs up. Awesome. Super excited today to talk about building on layer 0. I think just as a quick introduction, GM, my name's Matt, developer ecosystem lead at Layer 0 Labs. And I figured if we were going to talk about bridging, one of the most important places to start would probably be with the London Bridge, right? Real quick, just as an analogy, I think bridges obviously connect isolated groups of people, but more than just people, the really interesting bit is they connect information. And with information, you can do a lot of interesting things. You can coordinate the exchange of goods and services between these isolated groups and parties, and you can also create financialization between isolated groups using that information. Within crypto, it's very much the same thing. When we talk about blockchains versus L1s, L2s, et cetera, you're constantly deciding as a user and as a developer to make trade-offs between speed, cost, security, and also communities on top of each of these developer ecosystems. So really, when you're building, you'd like to figure out, how do I communicate between kind of these isolated islands? This has become more of a reality over the past year. If you look in 2023, the Electric Capital Developer Report saw that over 30% of developers in the space are working on more than one chain, and this number has significantly been growing year over year. And I think this makes sense, because if you look at the blockchain ecosystem, you have all these separate islands. However, you need a common way to communicate between each of them. And ideally, if you're going to create some generic standard for how you message between different chains, it needs to uphold the core principles of the blockchain itself. Namely, one, it has to be permissionless. Anyone or any smart contract can interact with it and interact in a way where they can't be censored, right? They can't stop the flow of messages between two different blockchains and prevent those islands from speaking together. And finally, it has to be immutable. You can't have code that's upgradable that can potentially brick your implementation and also brick every other application built on top of it. But taking a step back and looking a little bit closer to kind of the most standard form of application on a blockchain, token transfers, with one blockchain, it's relatively simple to know who you're sending from and who you're sending to. You're just updating the underlying ledger. But as soon as you move to more than one blockchain, you immediately have a problem. You have these walled gardens and these chains that don't know about each other, so how do you have a common standard of interacting between them? Ideally, we want some way to be able to transfer our funds on the source chain, get that debiting interaction to work, and then notify the destination chain to receive that asset in a way that doesn't violate any of the previous principles. Traditionally, the way this was done was using some type of monolithic bridge security. In the middle, the way you can think about this is a centralized provider or some type of collection of signers or a middle chain. It doesn't really matter. There's one validation technique that sits in the middle between these two chains. But what happens when that validation fails? This isn't more of a what if, but an actual literal scenario. If you look at the history of bridging, time and time again, applications promise some type of validation that securely transfers messages from a source to destination, but at some point, a validation technique either becomes stale, outdated, it fails, a backdoor is unlocked, there's a lack of client diversity, and what ends up happening is not just you, the application builder, but every application builder that touched that validation technique is now suddenly at risk. Looking at the history of blockchain, you can clearly see out of the 5 largest attack vectors and hacks that we've seen in the space, 4 out of those 5 were due to this type of monolithic bridge security, where one validation technique fails and every application underlying it is immediately essentially pwned, right? This is from the Rect leaderboard. You can check it out yourself. And going back to kind of that narrative we have about cross-chain being a reality, where we have different trade-offs that developers and users make between different blockchains, why should bridging be any different? Why should I have to subscribe to one monolithic model of security, one monolithic model of bridging, in order to move not only information, but assets between chains? Clearly, a better approach would be to have some type of standard for an omni-chain application, where I, the developer, not only have control over how these pathways interact and what validation techniques are used, but also know that my configuration is unique in a way where not every application is suddenly at risk when one validation technique fails. Looking at how Layer 0 solves this, this is from our omni-chain fungible token standard. At a high level, looking back at that token transfer logic we talked about earlier, all the OFT brings is a standard ERC20 token and implements a special debit and credit logic on the source blockchain and the destination blockchain. But the really interesting bit is in the middle here with the security stack. All a security stack is, and the way you can think about it, is another configurable field that an application owner can apply any access controls that you normally would have to, whether it's pausable, providing some type of multi-sig, etc. But what it applies in the middle is the ability to choose not only the size of security validation techniques that you're using to verify messages between chains, but also the type of validation techniques that are used. At a high level, what this means is that when you deploy on Layer 0, not only can you control the validation techniques that are part of this overall security stack, but in the worst case scenario, if one validation technique outright fails entirely, your flow of messaging is not stopped in any way, shape, or form. You can continue message passing safely because you have collectively signed and said, I want, let's say, 2 out of these 3 validation techniques to prove that this message is legitimate from a source blockchain. You're not underlying risk from just one validation technique that could fail at any time. Looking at a high level of how this actually works, any application, whether or not they're using our contract standards, can communicate with a Layer 0 endpoint contract on the source blockchain. That message uses a configuration that you own as the application owner that's stored on-chain in a message library. That message library controls not only what security stack you're communicating with, what validation techniques I'm using, but also how I want execution to happen on the destination chain. From there, configuration of those security signers will basically attest that that message is legitimate using each their own validation techniques. In the previous example, you saw there were 4 verifiers. There's 3 validation techniques that out of that 4 have to sign off here. It's enforced on-chain, on destination that, hey, this is the configuration of techniques that I actually want. And then that message can be permissionlessly executed by any user or automatically executed by a production asset that Layer 0 runs directly to the destination app all through the protocol. And what this means is that when you're looking at layer 0 and trying to build a cross-chain application, you don't have to subscribe to any one model. You can actually include all of them or any size, shape, or form of this collection for your security stack, whether that's a ZK Lite client that aggregates 300,000 signatures on Ethereum, whether it's a traditional messaging service like CCIP, an established Web2 entity like Google Cloud for sanity checking that, hey, this is actually making sense and I want to have some kind of insurance on the back that makes sure that this message is legitimate. It doesn't matter. You can configure any size, shape, or type of validation you want for layer 0 messaging. And broadly what that means is that your application is future-proof. As new verification schemas come out and become more available for the average developer and average user, you can easily configure your security stack to add that schema on board. Outside of just validation techniques, some of the other interesting bits that you can control are the block confirmations, for example, that you have to wait on a source blockchain before a message gets emitted. This protects you from reorg risk if your, let's say, application is based on a source chain that has high frequency reorgs that mess up the validity of transactions. You can configure, again, the security stack. So if I wanted, say, 2 out of these 3 validation techniques to sign off a message is legitimate. You can also abstract away gas from your users. Using automatic message execution, a user can only pay in a source blockchain's gas token and have that entirely swap for them on the destination chain for a 5 basis point fee and automatically delivered to the destination chain for execution. Or if, let's say, that executor disappears at any point in time, any user can permissionlessly execute that message on the destination chain as well. There's no limitation for what you can do here. On top of those executor gas settings, you can actually dive a little bit deeper and specifically price how much gas I want to use for the receive logic of my transaction. So let's say I minted a token on the destination chain, I have the amount of gas limit I'm providing, the message value for minting that token, and then I have a secondary transaction I want to execute after composing on that token transfer. So let's say I want to take that minted token and swap it for an ERC20. I can use the compose logic to not only define the gas and message value I want for that transaction, and I can also add native drop options to drop native amounts of gas to a wallet. Let's say I need to fund an externally owned account to help a user's onboarding experience on that new chain, or just fund a contract for it to use some type of pull method to pull that gas for a subsequent transaction. You can also configure the order of messages. By default, messages are unordered, so if a message fails in delivery, the subsequent nonces can continue to be executed without blocking the pathway. But let's say I have a niche scenario where I need to develop, let's say, for governance, being able to store that, hey, these users voted specifically in this order before a timestamp. I can configure within the application level that I want, if message 2 fails for some out of gas reason, that nonces 3 and 4 are blocked until nonce 2 is retried and cleared. Outside of that too, you can also configure the max message size, helping you standardize the data type that's actually being delivered on the destination chain, protecting you from overflow or underflow of inputs from a source. Really, what you can do with layer 0 is extend composability. Instead of having to rely on packing all of your contract calls into one singular function and hoping that it succeeds, else it reverts, you can instead atomically pack out multiple messages on the destination chain that you want to add on to your transaction. So in this example for here, I want to receive that OFT and immediately swap it as its own atomic transaction, thereby guaranteeing that if that swap fails, the minting on the destination chain still occurred successfully. Overall, this builds into what we view as an omni-chain tech stack, where any application, no matter what your use case is, can communicate freely with a layer 0 endpoint contract on any blockchain network and configure not only all of the settings aforementioned, right, but also know for sure that you're not at risk of any validation technique suddenly becoming outdated, prone to vulnerabilities, lack of diversity, etc. And so we're going to dive into a live coding example, and fingers crossed this goes well. That's our new CLI toolkit. I'll pull this back up at the end, but we're actually just going to jump right in right now. So here we go. All right, so just to get started, all you have to do to start building on layer 0 is run one really quick command, lz oap and latest. Make sure you're using node version 18. What this is going to do is create a boilerplate repo for you. Ignore the formatting there, a little bit funny, but basically it'll ask, hey, where do you want to start your project? Do you want to use the Omnichain fungible token or just the broad data passing layer? We'll choose OFT. What package manager I want to use? Do I want to install the dependencies? It'll pull everything down. And while we're waiting for those to get installed, taking just a brief preview of what is included in this repo, you can see that for contracts, it pulls in the basic OFT contract. All that OFT contract has is just, again, my OFT is inheriting the OFT standard. OFT is an ERC20 token. Asks you about, hey, what's the name of your token, the symbol, what layer 0 endpoint for what chain you're using, and then an owner for that contract, right? From there, you also get brought in some tests for you. You have Foundry tests and hard hat tests enabled by default for this package. If you want, you can use one or the other or both. Totally depends on what you want to do. But the greatest thing I think that helps with omnichain development is this hard hat config extension we've done. So super normal hard hat config. The only difference is that you have the inclusion of an endpoint ID that identifies, hey, what chain are we actually working with here? And then this layer 0 config file that basically extends that endpoint ID and says, these are the contracts that I expect to be working with on each chain. You instantiate them as part of the connection, and then can define whatever config settings you want in here. For lack of time, I'm going to jump to a repo I've already set up and jump in here. You can see I have 3 main contracts. I have an OFT mock, has an open mint function. Don't worry too much about that. I have this swap mock, which pretend this is a contract that you want to actually interact with on the destination chain. All it does is basically takes a composed message in, and it says, hey, once I receive an OFT from this token, or from this contract, transfer that ERC20 to the designated receiver on the destination chain. And so what we'll look at really quickly here is actually running this send and swap command. All I'm going to do is use this task that I built ahead of time that just says, hey, I want to send from Avalanche Fuji to this destination, Arbitrum Sepolia. I want to send to this swap contract address an amount to swap, a minimum amount to swap for slippage, and then these gas options, right? I want to use 200,000 gas for the minting and 50,000 gas for the composed swapping. This encoded compose message is just arbitrary bytes. You can pass anything in here, but let's run it and see what we get. So hopefully the internet works and my gas is funded, but we should be good to go here. Once we run this task, we will get out a transaction hash that we can plug directly into layer 0 scan. And so we're going to open. It takes a minute to index just for the source chain. Should take 15 seconds or so, provided nothing's gone crazy. Great, there we go. And so we can see from Avalanche Fuji, this is the transaction fee that we paid. We know who the sender is from the source chain. We know that the cargo within that transaction is one mock OFT that I'm sending from Avalanche to Arbitrum Sepolia. And then while that message is being delivered, it's going through those different validation techniques that the security stack is configured. And then once that validation is confirmed, the message will automatically be executed, and this will update automatically for you. You can see here, it tells you what the source application is, what the destination application is, the amount of gas we paid for the receive logic, the amount of gas we paid for the compose logic. You can see this execute button pops up once we know it's verified. You don't have to use this, but this is just in case the executor fails. You can see now we're confirming that the transaction is legitimate and we're delivered on destination. And so if you check my wallet balance here, you can see that I had 78, I'm down to 77. I hop on over to Arbitrum Sepolia. This mock token, I now have 10 of from 9. And if we actually go to the contract address, just to check that this hash is legitimate, we can see, great, down here, this LZ receive method was called. We got our minting at least through. And then from the compose end of the logic, what we'll do is just pull up the swap mock contract deployment on Arbitrum Sepolia. Nice. And pop on over to Sepolia scan. Great. Check ERC20 token transfers. And just to confirm, at the top here, you can see 1 minute ago, an OFT went in. And 56 seconds ago, that ERC20 came out to my address. And so really the limit is kind of endless here. You can do anything that you want with sending arbitrary payloads, and you're good to go as far as making sure that your messages are A, verified, that you know that anyone can come and permissionlessly execute these messages, and really start composing more and more protocols and more applications across multiple blockchains. Layer 0 also allows for message passing from, let's say, I want to go from chain A to B to C and any other legs that I want to go. All of that can be packed within your send logic, and you can have multiple kind of nested calls within one send transaction. But yeah, that's it for the presentation. Happy to take some questions from here.
Hi, thanks for the presentation. I actually have two questions. The first one is, Is there any easy way to migrate from V1 to V2? Because this is the V2, the new one, right?
Yeah. So there are two things that come with Layer 0 V2. There's the integration of that security stack, right? So if we talk about this end, right, being able to choose any provider as part of your security stack, that can all be migrated from V1. The way that this works is if you look in this transaction flow, we have a message library. The message library is append only. So for Layer 0 V2...
So the entry point is the same?
Exactly. For V2, what you can do is basically just say, hey, I want to use this new validation library that was appended to the registry, and you can start using the security stack and executor setup.
All clear. Thanks.
Yeah.
And the other question is testing omni-chain, like cross-chain protocols is quite hard. So you showed the example on the testnet, which was actually deployed. Do you have some kind of library that allows you to transfer, locally without interacting with blockchain?
I do, yeah. So we actually have this Foundry package called Test Helper, which recently got put out. We had to update it to OpenZeppelin v5 for some core dependencies. But what it lets you do is locally in your Foundry test define, hey, here's some mock endpoint IDs. I want to use 1 and 2. I want to deploy an OFT on each of these endpoints, define some users, and then test through essentially wiring these contracts together, minting some initial balance, and then testing the send function locally. All you have to do from this end, should just work out of the box once I pop in here, is just run your normal Forge test commands, and then we'll be good to go. But yeah, test helper you can find docs on docs.layer0.network, and everything within that repo that I published will kind of show you kind of how to work through a lot of the local examples as well as kind of the deployed examples through testnet and using Layer 0 scan. Yeah. Any other questions?
Hey Matt, great job. You mentioned something about native drop messaging. I think it was about potentially airdropping to make it easier for new users not to pay gas. Yeah, what was that?
Yeah, so basically within your executor options, I think I showed you when we were doing that send example, there's that add executor LZ receive option, block a gas, add executor LZ compose option. This .native drop option can be another one that you append onto it. All you do is basically add that configuration to your send call with a destination receiver address and then an amount, and you can airdrop that destination chain's native gas token direct to that address, all as part of the send call logic.
Okay, cool. Thank you.
Yeah. Cool. Any other questions here? Or are we good to go? Like I said before, feel free to try out this package while you're hacking. I think it's super handy to get up and running for cross-chain applications, and we have 2 bounties, one for OAP worth $2,500, one for OFT worth $2,500. So thanks so much for having me, guys. Yeah, cheers. Appreciate it.
and it's the Avail 101 workshop. As usual, guys, if you have any question, please let me know, and I'll come with the microphone to you. Thanks.
Cool. I think I can start. Guys have to wear headphones, I guess, so we can do it from like that. If you cannot hear me, let us know, and they can fix it. So today we'll be covering, the very basics of what is Avail and how to exactly use it, and what are the different tracks that we have here. So, I mean, the big picture we all know that rollups are taking center stage. There are, we are already seeing a huge explosion of the number of rollups in the space, and these rollups are all hungry for data availability, and that is why we are building Avail DA. It's the data availability focused blockchain powered by KZG polynomial commitments and validity proofs, and also data availability sampling, which is one of its superpowers. Now, in this world of hundreds of general purpose rollups and app specific ones, how will the user experience look like? We think that it will be very fragmented, because as you can see, there are with many different L2s what's happening with the user experience with different wallets and such. It's very easy to see that there needs to be a force which composes all these experiences together to provide a unified experience. And that's where we come with Avail Nexus. It is a way to unify the rollups across the ecosystem via proof aggregation and data availability sampling. How it works is that we create a coordination rollup on top of the Avail DA, which has two main functions, the sequencer selection and proof composition. By unifying, then one rollup can talk to the another by verifying proofs rather than by relying on the other for executional correctness. So it can verify both executional correctness through validity proofs that the rollups generate, and data availability sampling proofs to know that that data is available. Now, once you have the Nexus and the Avail DA, you need a very robust security which anchors the entire protocol, and that is where it comes with Avail Fusion, where we want to have extra external assets like a BTC and ETH and so on to power the base layer. So that's what we call as the Avail Trinity. It composes of the Avail DA, the Nexus, and the Fusion. Today, we are going to mainly talk about Avail DA because that is the one which have been developed for some time now. We have been developing it for around 3 years. That's what we are going to launch on mainnet very soon, and it will be very useful if you guys try it out, let us know, have any feedback on top. So what is this DA and how does it work? So essentially it's a very, very simple, it's a dumb blockchain. It doesn't do anything fancy. What it does is that when you submit a data blob, it keeps it available. That's the only job almost what it performs. So how you can think is that there are this plethora of rollups which are building on top. You take the transactional data or the state deltas from these rollups and put it on Avail, and then you have a verifiability. You have verifiability, so which means that you get a guarantee that the data is indeed available. How you do that is you check the availability against KZG polynomials, polynomial commitments, and you do that using sampling. So you don't need to download the entire data again and then verify whether it's available. What you do is you just check the commitment and then sample bits and pieces of it. And by the cryptographic guarantees that we give, you will be able to get a very, very high confidence that the data is indeed available. Nexus, again, I will probably skip a little bit on this because this is not probably very, very relevant, but I'm happy to discuss further with you guys after this presentation because I have been put on a very tight schedule here. Same with Fusion, just that one of the core features that we want to have here is that all these assets should play a role natively inside the consensus, and that is going to be extremely important because we don't want to create extraneous forces outside the consensus system that affects the outcome of the protocol. We want to bake it all inside the protocol, and that's one of the core differentiators from other solutions in the space. And that's how we think that Avail will accelerate the unification of Web3. Let's talk about the DA a bit more. As I said, it's just a modular blob space, right? So it has a very simple way of publishing the data. Each rollup build that is built can interpret and define its own transactions. So we as Avail do not interpret transactions. We do not, decode it or anything. You can build anything completely custom. You can have your own state transition functions built on top. You can have anything from EVM to no VM at all. And we will probably come a bit on that as well today. One of the, a good thing to note here is that you can segregate the transactional data per application based on something that we call application ID. So if assume that there is this Avail block and all of you here use the same block to submit all the data, then to know which part of data is important for your application. You don't want to download your peer's application data, right? So how you segregate is that you create an application ID, and against that application ID you send the data, so that you can get back only those parts which are relevant to you and not the entire block, because the block can be pretty big for your application. As I said, we use polynomial commitments and data availability sampling. What you can think of here is there are 2 or 3 modes in which the light client can work. One is what we call as a sampling mode. In the sampling mode, how it works is, as I mentioned, you randomly select a few parts of the data, get them back, and check it against the commitments. That's your guarantee that almost entirety of the data is available. This guarantee only comes because of the erasure coding there. So for a block producer, it's extremely hard to censor parts of the data, because if you censor a single part of the data, you have to hide a lot of them. And if you hide a lot of them, then by sampling, you will be getting caught. And that's one of the reasons why data availability sampling is so powerful. There's another mode in which you can run, which is called application full nodes, in which, as I said, you can download only the part of the data which is relevant to you. So you run a light client, but you feed it a particular application ID which is relevant to you, so that you download only the parts which are relevant. Now, what this all allows is that there's a vibrant ecosystem waiting to be built on top. Right now, we have all seen about the Validiums, the EVM general purpose chains, but there's a lot more that you can build. You can build an infrastructure on top, like an L3 sequencer. You can build a Validium. You can build state verifying bridges and use asynchronous composability among these rollups. You can have shared security because your Avail DA acts as the source of truth for the entire ecosystem. Roughly speaking, again, not super relevant, but it's good to keep it in the back of your head if you are building something on Avail. What the Avail block does is that you take the original data, you extend it. That's the erasure coding part, which makes it highly hard for a block producer to suppress parts of the data. You encode them all up inside the header. The header goes on to all the validators, and if you suppress only a part of the data, then also you can catch it, because that's how sampling will work. I'll probably ignore a bit of these things here, but again, one of the things which are relevant here again is how we compute those commitments. If you have the data blobs like this, we take it as a matrix and we create commitments. How many commitments do we create? We create 256 commitments. If you have seen the latest EIP 4844, and we will come to a bit of it. How EIP 4844 works is that you have at most 6 blobs, each of 128 KB. Here we have 256 blobs, each of 256 cells, and each cell is 32 bytes. It's the same cell size, is the same curve that EIP 4844 uses. So that's one of the the good things that has happened, because currently all the rollups have switched to blobs or are switching to blobs, and blobs are the native data structure which is supported by our chain, and it uses the same KZG commitments which are used in EIP 4844. We use a consensus called Babe and Grandpa, and there are, of course, tons that I can talk on top of it, but the main thing for you to know is that if you send a particular data to a block, the block will get finalized in almost around 60 seconds. So 20 seconds is our block time, around 40 seconds to finalize that block. So it gets a total of around 60 seconds. If you use any other DA layer, that is any other DA layer, you will get a guarantee of data availability much later than this, orders of magnitude later, because Ethereum finalizes every 12 to 15 minutes, and any other protocol might rely on fraud proofs, so they have much delayed guarantees of DA. No need to go into the staking details, but that is one of the core, decentralization factors that we have on our chain. We use something like nominated proof of stake, which uses a fragment election algorithm on behind the scenes, and that's what keeps our validator set very much decentralized. And you cannot, even if you try to centralize it using a huge amount of stake on all delegated into a single validator, the algorithm will not select your stake. This is one of the major parts where the differences lie. This is the light client network. There are the blocks. As I was mentioning, there is sampling, but these light clients form a peer-to-peer overlay network of their own, which means that the light clients can host an entire block replica. Not going into much of the details, we will see a little bit of that, but what can you build on a whale, right? We will give you some more examples, but you can build anything from validiums to optimistic chains to sovereign rollups to app-specific ones to general purpose ones to even L3s, L4s, God knows what, right? So anything which needs a transactional data to be secure, you will be needing a DA layer, and you can try out a whale. This is the part about the bridge. How a whale and Ethereum talk to each other is through an attestation bridge. It's a ZK verified light client based bridge that we have built in collaboration with Succinct. It uses, like, the Ethereum blocks are verified inside a whale and vice versa. That means you can have the attestations that you get on a whale, you can propose them to the Ethereum, and that is one of the ideas that we have for you guys, is to try out the bridge, either to make a JavaScript SDK on top or to make this Validium using the bridge. Probably you guys know all about what are sovereign rollups and how it works and so on and so forth. Let me get into concrete details right now about the tracks that we have. This is track 1. The track 1 has almost nothing to do with a whale. What we want you is that create the best visualizer that we have for pre and post EIP 4844 and compare the cost and the benefits that we have after EIP 4844 came into place. There is a $2,000 bounty which we want to give to 2 people. The criteria for evaluation is the number of rollups that you can support. Now, mind you that there is a certain diversity in types of the different rollups that you can build. So for example, if you take a look into something like, let's say, L2Beat, and maybe I can open it as well for you to see. If you see L2Beat and you go through all the rollups that are mentioned, you will see that Arbitrum 1 is a type of its own. So it uses the Arbitrum Orbit stack behind. If you see the OP mainnet and the Manta Pacific, they are both using the Optimism stack. So by looking at the Optimism stack only, you can cover a lot of these chains that are there. Similarly, you will see that ZK Sync Era is a chain of its own, but there are others like, for example, the Starknet, DYDX, Immutable X. They are right now using the stack. And how do you know the stack? You will see that with what stack was it built. So when you support a particular stack, you can support multiple of these rollups. So you can take your pick about how do you build the best visualizer and make the most of the chances that you have. We will be evaluating by the diversity in types of the stacks that you support, but also the number of L2s whose costs are being visualized. Of course, the design and presentation is going to be key because we want it to be the best visualizer that we have. There are a few others that are there in the space, and that's also good to see. For example, there is this blob scan, which you can see that for every block, how many blobs did it contain. And as I was mentioning, on Ethereum, right now you have 6 available blobs, but only 3 on average because of EIP 1559, EIP 1559, which says that on an average the capacity will be half. Just like in the transactional gas estimation things, you have around 30 million block gas limit, but only 15 million on average. Here also you have 6 blobs in total, but only 3 blobs in average. And that's something to see here. Also, one of the things that to mention here is that even if rollups are using the blobs, they are not using it completely. They are using it partially, and that's also something that you can show. Because if they are not using a blob completely, and this has been happening in StarkNet, so from EIP 4844, we kept on they kept on increasing the capacity utilization, and right now they are reaching around 60 to 70% of the blob space utilization, and that's very good to see on an explorer like this. So that's something that you might want to consider. Right now, as of today, as far as I know, zkSync, StarkNet has already, and Optimism has already started using blobs. Arbitrum DAO has already approved, may have been already included. I have not seen the latest, but these are all using EIP 4844, so there is a lot of comparison that you can make. One of the bonus points that we want to give here is the simulation of congestion. So suppose you have all the rollups sending all them not as call data but as blobs. If that happens, then the amount of congestion and the cost estimation, if you can provide that inside the visualization, then we will give you bonus points there. Hopefully that makes sense. If not, let's talk outside or after the presentation to discuss some more of these details. Last thing here, yeah, I think here also, as you will see, that zkSync, Optimism, Base, they have all started using blobs. In each of these blobs is 128 KB. You see there's a fixed size of blobs. This data, sometimes you will see a lot of zeros amended. Of course, this is a filled up blob, so might not, like, it might be fully utilized or almost fully utilized. But sometimes you might have padding on the end, which will tell you like how much of it is being actually used. Now comes the interesting track, which is around $3,000, 3 each of $1,000, I guess. Here, build anything with Avail, and we are not trying to give these as pointers or what you should build, but these are just some suggestions about what are the kind of things that you can build using Avail. The first is build a custom application specific rollup. What that means is use any stack of your choice, be that Madara. On Madara we have docs. You can just pass a command line argument while using the Madara stack by the Starkware guys, and you can use Avail DA out of the box. When you use Madara, then build something cool on top and show that it is using Avail, and let's see the impact that you can make by using something novel. Rollkit also, we will have all of them in the docs. You can check out the docs and see step by step about how to use Avail using Rollkit. What Rollkit enables is that you can use any Cosmos SDK chain. On the latest version, any Cosmos SDK chain can be used to build a rollup on Avail. RISC-0 and SP1, both of our partners, what they do is that you can take any C++, Rust, mainly Rust I would say, program which compiles into LLVM and make a verifiable compute on top. What that means is that with this, you can have any arbitrary logic as a Rust program and building that as a rollup on top. Right? And that's one of the powerful primitives that you have today. What you can build on this, let's say an order book exchange rollup, right? Now make, like, if you think about an order book exchange, till now EVM had severe limitations of the type, on the kind of things that you can build, the amount of state that it can support, the number of loads, like the number of reads and writes that it can do, the amount of order matching that you can do off chain, and the verification that you can do on chain, and so on and so forth, because you didn't control the protocol. You do not control how your transactions are selected from the mempool. You only control the EVM compatible logic. Here, with an application-specific rollup, you can control everything, starting from your sequencer, which decides which transactions get in what order, to the executional guarantees that you want. What do you want off-chain? What do you want on-chain? What are the verifiable parts? What are non-verifiable parts? You can decide, and that makes you, able to build a lot of different things which you couldn't have been building in a general purpose chain. Of course, for this to be eligible, I think you will have to use Avail as a DA, of course. And I think there are other tracks from many of our partners who have also had bounties if you build something on the DA space. You can build a liquid staking protocol for Avail. One of the core problems in a liquid staking protocol is that Avail does not support smart contracts. What that means is that if you have to build something, either you will have to build it directly on the node as a pallet, or you will have to use Ethereum to build something and then bridge assets. Now, while bridging assets, you will have to also think about how your tokens which have been staked on Ethereum, how they will be bridged through the bridge and then directly staked on the protocol. So that's one of the tricky parts of building a liquid staking protocol for Avail, but you can be innovative. There might be things that we have not thought about, and you might be able to unlock one of them. Again, take a look into the other tracks. Maybe some of them are also eligible for other prizes elsewhere. This is something pretty cool in my opinion. If you check out our light client, our web light client is a simple page. What it does is it does the sampling. So as you can see here, it's a very small block that we have here. But again, you see that it got changed and the next block was pretty big. This, of course, inflates and deflates per demand. And this is the live sampling that is happening. One of the things that are lacking here is that, of course, everything happens here, but there's no peer-to-peer connection. And we definitely want to rely on peer-to-peer more than we want to rely on RPCs. This is all built in RPCs. All the KZG verification is happening inside the browser. And that's one of the cool features that we have here. What you can do is you can add peer-to-peer support on top. And here you can use a JavaScript lib peer-to-peer library to make it on the JavaScript side, or you can use it on the Rust side by using Wasm. And this application right now already uses Wasm to verify and Rust code. Again, more and more ideas. We have a bridge API which is powered by Rust. It connects and uses people can use this API to send transactions from one side to the other. You can build a JavaScript SDK on top so that wallets can use that for bridging. These are some of the more advanced. If you are interested in peer-to-peer, there's an address book that you can build. You can detect the addresses. You can store it all. There are some bonus points about how you keep the mapping, the WebSocket communication versus a TCP communication versus a bootstrap node or a non-bootstrap node, and so on and so forth. There are other things which you can build if you are more interested in something like IoT, if you play around with Raspberry Pis and others. If you can build, if you can embed the Avail Lite client inside the Raspberry Pi and build a web app on top, that would be a cool thing to build for the entire community, because our decentralization depends on the number of Lite clients and the ability to run Lite clients, because we give the highest form of guarantees to our Lite clients. I think these are all Q&A, but before I go there, let me be a little bit more hands-on. So, how to run a Lite client? It's very simple. There is a repo called Avail Up. In that, this is a simple script. If you run this script, it will automatically fetch the latest. It will run the Lite client. It will generate addresses. It will do all the things that it needs to do to be able to run a Lite client. When you run a Lite client right now on the Goldberg incentivized testnet that we are running right now, you might get an error or a warning on the bootstrap. Ignore that warning for now. We have multiple bootstraps. The first bootstrap is giving a warning here. Ignore all of that. This is a Lite client running. When you are running a Lite client, you can also use the HTTP interface on top. I think this. So what you can do is on the Lite client, you can, yes. So you can see the status, what network is it connected to, what versions are it using, everything. This is the V2 interface. The V2 interface is somewhere here. So you see the API version V2. You can see the blocks, the sync status, the block numbers, etc., etc. You can even go and submit a data using our Light client. So this is all happening through the Light client. You are not connected to an RPC directly. You are connected only to a Light client, and you can post a particular data. Here I'm posting this data. This is all base 64 encoded. You can use this data to go ahead and submit onto a whale. Why are we waiting here? It's because this is getting submitted. Once the submission goes through, you will get a transaction hash. Using the transaction hash, you can go to an explorer. We have 2 explorers that we have right now. Two have different properties. So if you put the transaction hash here, you will be able to see the submissions. It would look something like this. Yeah, I think you will be able to see what kind of data that it had, what kind of proofs that it generates, and so on and so forth. You can do the same, but using something like Golang. I think this. So you just need to put in this, and then the data can be submitted directly on a whale, and this is the data that got submitted right now. You can also use something like JavaScript. So this is a JavaScript example. Just do an npm run data submission using our whale.js SDK. You will have to wait till it gets submitted, but once it submits, and again these are warnings and other information, you will be able to see something like this. Here again, this is the data that got submitted, the transactional details, the payments and all. You can ignore most of it. But once you have all of this, you can also use Rust, by the way. Our Rust examples are here. These are the examples about how to generate account from a mnemonic, how to use the bridge to send messages, how to synchronize the latest header, how to query a proof, submit a data, and a few other things that are there. Again, all the examples on how to run are all here. You can check it out. The same goes for Go examples. The Go examples are here, how to connect to a node, how to submit and then wait for its inclusion, how to query the proof data, listen to new blocks, transfer funds from one node to the other, and so on and so forth, right? So all of these are Go examples. The same with JavaScript. You can see here like connecting, creating an application ID as I was mentioning, and so on and so forth. So yeah, these are all examples. Hold on. Okay, cool. So yeah, I think that's almost it. There is a Telegram chat, there is a Discord. This is a Discord server where we can chat a lot more. There's a Telegram chat there. We can discuss. And if you have any questions, reach out to us. This is me on Twitter. That's a Will project. Thank you.
By Ian from WordCoin. And as usual, please, if you have any questions, just let me know so I can bring the microphone to you. And yeah, that's it. Thank you.
All right.
Hi everyone, I'm Ian. I do developer relations for the WorldCoin project, specifically working for Tools for Humanity. And in this workshop, I will go over what World ID is, why WorldCoin created it, what you can do with World ID, and most importantly, how to integrate World ID into your project. So, World ID is our global proof of personhood protocol that allows you to prove that you're a real human doing an action only once without revealing to anybody, not even to WorldCoin, which unique human you are. Right? This is a really big, important question that we're answering. Bots have gotten out of hand and will only continue to get worse. Sybil resistance is a huge problem in this space. And basically any project benefits from knowing that that user's a real human and that they only have one account. World ID is built to be private, inclusive, and robust, right? All we want to know is that you're a human. We don't really need to know which human you are. As many people as possible need to have access to World ID, and we want it to be robust, ensuring that it really is just one verified World ID per real human. We looked at a lot of different ways to go about solving this problem, but an email or phone, it's easy to get multiple of those. We looked at doing KYC of government IDs, but less than half of the global population has a digitally verifiable government ID. Webs of trust work well at smaller scales, but scaling them to all of humanity is a really tough problem when your initial trusted set is only a couple hundred or a couple thousand people. But biometrics can do a really good job of proving that you're a human and proving uniqueness. When it comes to biometrics, there are lots of different types of biometric markers we can use. We looked at fingerprints, face scans, palm scans, but those can change over time. They don't scale super well to all of humanity, right? Face ID and Touch ID on your phone can distinguish about 1 in 30 million people. That works fine for one-to-one authentication, but doesn't do super well when you're trying to prove that you're different from millions or billions of other people. DNA, very, very unique, but it also isn't private. It tells us a lot about who you are, and that's not information we want. So we settled on using the iris. Lots of uniqueness, does not change very much over time, and another benefit of it is that it's something that's really hard to do passively, right? You can't just snap a photo as someone's walking by. They have to choose to look into the device that we use, the orb, which you'll see in a second. And if they don't want to get signed up, they can close their eyes, look away, which is good. Consent is an important part of any system involving biometrics. So when it comes to how we actually interact with biometrics, we looked at phone sensors, but the cameras just aren't high enough quality, and it's somewhat difficult to trust that that device hasn't been tampered with in any way. Off-the-shelf hardware is better in terms of trust, but it's usually not very portable. It can be expensive. So we settled on building custom hardware. And that is the orb, which you've probably seen at our booth, seen at locations around the world. And the orb has been in development since late 2019 and gone through lots of different revisions to get to where we are now. And the orb has a really important job. It checks to make sure that you're a real human, not a cat, not a dog, not someone holding up a photo of a human. On the device, it calculates an iris code, a digital representation of the pattern of your iris, so that we can use that to prove that you're unique without having to store the images of the iris. By default, the images taken by the orb are simply processed in memory and then deleted and don't need to be stored at all. And then, once we have verified that that iris code hasn't been signed up at the orb before, it verifies your World ID. World ID as a whole is built to be privacy first, decentralized, and open source. Any information that we don't need to know in order to prove that you're a unique human, we don't want to collect, don't want to store. It's designed to be decentralized, and we have a wonderful blog post that can go more in depth about that. And it's open source. Everything relating to the protocol is already open source on GitHub, all of the smart contracts, the sign-up sequencer, all of our dev tools. And then the Orb hardware is open source. The Orb software will be open source later this year. We want to be fully open about it. There's lots of different use cases for World ID. Voting is a great example. You want to know that each real person only gets to do a single vote. Social media, it's great to know that that account doesn't belong to a bot. Customer incentives is one I find particularly interesting. I have made a lot of emails to sign up for a lot of Netflix free trials, but World ID can prevent that. And World ID is also super easy to integrate. You can use it on the web, you can use it on mobile, you can use it on chain. And there's two main ways to integrate World ID. Sign in with World ID. Our OpenID Connect provider works just like sign in with Google or sign in with Facebook. And then we have incognito actions, which are much more powerful and what you can use for on-chain applications as well. So I'll start by going through sign in with World ID, and let's see how it works. So here, I'll go ahead and sign in to our developer portal at developer.worldcoin.org. And I use World ID to sign in. So I'll hit login. I'll sign in with WorldCoin. And then from within World app, I'll scan this QR code. It'll load for a second. The Wi-Fi at hackathons is always a little bit worse than we want. There we go. So I can see that I'm signing into the WorldCoin developer portal. It's a verified application, and I'll tap Verify with World ID. And then I am signed into the developer portal. In the dev portal, I can create and manage applications and actions, everything like that. I'm happy to walk through that outside of the workshop because I want to get through some of the code. But signing with World ID is super, super simple to use. And there's lots of different ways you can integrate sign-in with World ID. You can use our Auth0 integration if you already have other sign-in methods with that provider. You can use Next.auth.js. You can directly use some other OIDC library and use our OIDC well-known file to configure that easily. You can custom implement the OIDC flows. But I'll walk through how you can do it with Next.auth.js, which is what our sign-in template repository uses. And really all you need to do is add this sign-in provider to Next.auth's configuration, and everything else related to sign-in gets handled automatically. Right, so we have this provider that we'll call WorldCoin and use WorldCoin as the ID. We configure that well-known file, which is part of the OpenID standard, and tells it, here's where you redeem an authorization code, and all of the technical details like that is part of the standard. We have to input the client ID and client secret that we get from our developer portal. We'll use the ID token flow, and then we'll map information to the user's profile. So the profile.sub, that is part of the ID token format. That will use the nullifier hash, the unique identifier of the user in the context of your application as the ID. And then for the verification level, that should be renamed to verification level here, that's my bad. That will tell if the user is orb verified or device verified, right? Orb is this gold standard for knowing that that's a real person who only has one account, but for users who may not be able to access an orb, we also have the device credential, where the World ID wallet will verify that that is a real version of the app. It is a unique device with only one World ID associated with it, and it's a weaker credential in terms of proof of personhood and Sybil resistance, but it still is a way the user can sign into your application, and your application can know which verification level that user has. So now that I've gone through sign in with World ID, I'll talk about incognito actions, which is what most of you will likely use in the hackathon. With incognito actions, you can know that your user's a unique human doing something only once or however many times you want. You can set that to be unlimited if you'd like. You can let someone do something just 3 times. And with a specific signal, and that signal is a piece of extra information that you include with the World ID proof that can't be tampered with. So for voting, for example, that could be which person someone's voting for in an election. So you know that when the user verified with World ID and created that proof, they wanted to vote for this person. And when you're verifying that proof, you can ensure that the correct vote is actually counted. When using World ID, you'll use IDKit, our front-end widget. which will display a QR code the user scans that includes information about which application and action that user is verifying for. On the mobile device, a zero-knowledge proof will be generated and then returned to your app, and your app then verifies that proof either with our developer portal API for off-chain use cases or with our smart contracts on-chain. Right? And this is what that proof looks like. We have the root of the Merkle tree against which the proof is generated. On Ethereum mainnet, we have a Merkle tree that is essentially the list of world IDs that have been verified at the orb. The nullifier hash is the unique identifier of the user in the context of your action. The proof is a very long hexadecimal string that is the actual mathematical zero-knowledge proof, and then which verification level that user verified with. So let's see what incognito actions look like. So we'll use the try it out page on our docs as an example here. And we'll go with staging because we're going to use the simulator here. The simulator is what you use instead of World App for our staging environment. There's lots of different identities that you can test with. So if you want to test Sybil resistance, it's sort of difficult if you only have one identity you can test with. But we'll go with staging. We have our test action, and we'll have a minimum verification level of orb verification. So I'll tap continue with WorldCoin. This button can say whatever you'd like, but it opens up the widget here. And if I'm running the simulator on my phone, I can scan the QR code with the camera, just like I did in World App. But I can also just click the QR code to copy the information and paste it here in the simulator, just the same as scanning it. I'll go ahead and verify with the orb verification level. And then this queried our developer portal API to make sure that proof verified correctly, and we can see that it did. Now, let's say I want to try verifying again. We'll see that it won't verify because this person has already verified for this action. So any use of incognito actions will start with ID kit. And it's a single React component. You can also use it in vanilla JavaScript as well, and we have a separate package for that. But all you have to do is configure your app ID and action that you got from the developer portal. There's 2 callback functions. OnSuccess is required, and that's the function that gets called after the ID kit widget is closed. Handle verify is useful if you're doing off-chain proof verifications with our API, where you can verify that proof while the widget's open and display an error to the user in a pretty way, but handle verify is optional. And then you can set the required verification level. By default, that's set to orb, but if you set it to the device verification level, your app will accept proofs that are either from device verified or orb verified users. And then we have this child that is the button that opens that widget. So you can style that however you'd like, make the text whatever you'd like, but it just has to call open on the ID kit widget to cause it to open up. And this proof response that you saw earlier is the input to the onSuccess and handle verify callback functions. So we have that proof, but we have to verify it. And I cannot make that clear enough. You have to verify that proof. To verify that proof with your API, the first thing you should do is take that response object and pass it to your backend. If you want to do this proof verification in a controlled context, because in the front end, the user could modify anything there. They could just trick your application into thinking that they are verified. In your backend, they don't have that sort of control. So all you have to do is make a single request to our developer portal API. So it'll be developer.worldcoin.org/API v1 verify and then your app ID. The request body will include the action, the signal if one was provided, and then all of the information from that proof response object. And then the response will be a 200 if the proof verifies and if the user hasn't already performed this action the maximum number of times. For API verification, you set that in the developer portal, however many times you want to let the user do that. And if the response is successful, then you should go ahead and do whatever action it is that you wanted to gate behind World ID, whether that's marking the user as verified in your database or whatever else. But if it's a 400 response, it will include an error code indicating why it didn't verify, and it will, you shouldn't do anything except present that error to the user at that point because they're not verified with World ID. This one's, like, the API verification is quite simple, but now we'll get into the on-chain verification. So we have a template repository for the cloud verification as well as the on-chain verification. The on-chain verification, I especially recommend using the template repository. But to start, in our constructor, there are 3 things that we need to set. World ID is the address of the World ID router. The address book in our documentation can get you the correct address based on which chain you're deploying on. And then the app ID and action ID, again, that you get from our developer portal. And in the constructor, we should compute this external nullifier. It's a combination of the app ID and action ID that's used specifically to just denote which action that user is performing universally. World ID as a protocol is based on semaphore. If any of you are familiar with that, you'll probably recognize that term. Just for us, having that app with actions within it makes it a bit easier to do multiple actions within one application and still display that application to the user in a pretty way in World App when they're verifying, so they know what they're verifying for. And then we'll have a function that can be, in this case, named verify and execute. You can name it whatever you like based on what the user is doing. So this should take in the signal, if you're using one, again, the root of the Merkle tree, the nullifier hash, and that proof that you get from IDKit. So the first thing we'll do is check if we've seen this nullifier hash before, right? So we have a mapping of the nullifier hashes, and in this case, just to a Boolean value, where when we verify a proof for a specific nullifier hash, we'll set it as true so that we make sure this user can only do this action once. For on-chain verification, you do have to implement that Sybil resistance in your smart contract yourself, in contrast to API verification where we handle that for you. But once we've checked and made sure the user hasn't done this action before, we will go ahead and call verify proof on the World ID router, and we'll pass that the root, the group ID, which is 1. That should be just a constant in your contract. That group ID determines which credential we're verifying for, but only the orb credential is supported on chain at this time. So you can hard code that to 1 if you'd like. And then input the signal. So we ABI encode it and hash it a specific way for the protocol. That hash to field function is defined in our smart contract template. We also have to input the nullifier hash, that external nullifier determining what action the user is performing, and the proof. And if that proof verifies, the contract will continue. But if that proof doesn't verify for whatever reason, it will simply revert at this point. So once that proof verifies, we should mark that nullifier hash as true. We've seen it before, prevent the user from performing this action again. And then at the very end of that, that's when you can perform the actual action your user wants to do, whether that is minting an NFT or whatever else. And that is a great overview on how to build with World ID. Worldcoin.org/London24 will take you to a Notion page with a bunch of resources for you. Our template repositories, documentation, developer portal, bounty info. And if you have any questions, I am happy to go ahead and take some now.
So the zero knowledge proof, when you want to prove the action, is generated by your app when you are scanning the QR code. So my question is next. When you are using a third-party app, for example, on iPhone, can you somehow call the app of WorldCoin in order to generate this zero knowledge proof of the action? So you can submit it on-chain from your app, not from the WorldCoin, and not from the front end on browser.
We will support that in the near future, but at this time you do have to use IDKit for generating that proof.
Is the code base of this ID kit so hard? Maybe we can try to port it to...
You're more than welcome to try. It is written entirely in TypeScript, but it is open source. I will encourage you to try, and I'm happy to help.
Yeah, another question. So let's say for the cases where you want to have a proof of personhood for your, let's say, social media or something, that one person can only create one account and protect this way from the bots. What do you do for the case when the person loses access to their account? Because normally they would go and create another account, but in this case they won't be able to create a new account because there is an action that can only be done once and it's already done. So how do you go about this issue?
That is a great question, and with that, I would say that typically you should, if you are using our sign-in provider, for example, you should encourage the user to set a second login method, such as email password, connecting a wallet, whatever that may be, so that if they were to lose access to their World ID, they can use that other method, and if they lose access to that other method, they can use their World ID. For something using IDKit, what you can do is set it to a higher number of times that you're allowed to perform that action, but make it so that that nullifier hash can only be associated with one account at any given time, right? So say it's an application where my wallet is my sign-in. I can associate my wallet address with my World ID nullifier hash in your application's database or on-chain. But if I go to verify a different wallet with that same World ID, it will just remove the associated nullifier hash from the first wallet.
Hi, thanks for the presentation. I have a question regarding anonymity, because you mentioned that WorldCoin could be used. One of the use cases is e-voting, right? And how do you disallow linking the person, the data that you get to the person, or two different actions, for example, two different votings by the same person?
So the whole point of how World ID is designed is that it is anonymous, right? So in voting, for example, if those votes are two different actions, which they should be, that nullifier hash, for me, if I vote with the same World ID on both of them, I would have a different nullifier hash, and the point is that you can't tell that those two votes came from the same person. It's better for privacy. As for that person's identity, right? We don't have information on that person's name, address, government ID number, anything like that. So this can work really, really well for something like DAO voting. And you can do one person, one vote. They have to connect a wallet, show that they are a member of the DAO, but preventing one holder who has a bunch of the token supply, for example, from being able to just outvote everybody else because they have so much of the token. And if any of you have any other questions in the future, you can come find me at WorldCoin's booth, and you can also ask in the Partner WorldCoin channel in Discord. Thank you.